Often in geometric reasoning we'll have a question that's based around the idea of similar triangles. Two triangles are similar if one is effectively just a bigger copy of the other. So these two triangles look like two copies of other, just one bigger than the other. We can confirm that by looking at the angles. So if, for instance, this was 60 degrees and this was 50 degrees, if this triangle here also had an angle of 60 degrees, and it doesn't have to be in this same orientation, but this time it will be, and 50 degrees, then we can say that the two triangles are similar. When two triangles are similar, one's just a bigger copy of the other, and the ratio of the sides stays the same. So if, for instance, in this triangle this side was 4 and this side here was 3, when I make a bigger copy, if this side is 6, the side from 3 is growing to 6, the side from 4 must grow to 8. So the ratio of those sides stays the same. Now, like I said, it doesn't matter about the orientation. I can have a triangle here and another triangle here, if this here were 60 degrees again, and this one here was 60 degrees, then these two triangles are similar. When they're similar, the ratio of the sides stays the same. So if this side here was 10 and this was 15, I would know that every side from here, when I go to the corresponding side in this triangle, would be 1.5 times the size. So if this was 12, then this side here would be 1.5 times the size of 12, which is 18. I was told that my 10 grew to 15, so my 12 must grow to 18. If I was told that this side here was 20, then this side here has to grow to be 20. What number grows to be 20? Will be 20 divided by 1.5, because 1.5 here is our scale factor going from this triangle to this triangle. 20 divided by 1.5, it's not a whole number this time, but that shouldn't matter. 20 divided by 1.5 is 13 1/3. Excuse me. When we have similar triangles, we'll be looking at the ratios between the sides and the corresponding angles. The angles, if we can show they're the same, means there's that ratio between the sides happening. Quite a classic one is this idea here. If I'm told that these two sides are parallel, that means that this angle and this angle must be the same, because they're alternate angles on parallel lines. I also know that these two angles must be the same because they're vertically opposite angles. So now if I know some side lengths, I can use the idea of similar triangles to work out the side lengths in the other picture. So if this was 10 and this was 6, I know that 6 is growing to 10 or 10 is shrinking to 6. If this here was also 10, then this side here, which corresponds to that, see how it's between this marked angle and the unmarked angle? So again, between this marked angle and the unmarked angle, that would also have to be 6. The ratio stays the same. That's the principle of similar triangles.